Hello, welcome to this lesson on our study of partial differential equation. So, if you have not subscribed to my channel, kindly subscribe for more videos. In this lesson, we'll talk about what we call the transport equation. Okay, so the transport equation is actually a first order PDE that has time as the one of the independent variables. Okay, so you can see that we have a derivative with respect to t. Okay, here. And that is what makes this a transport equation. Okay, so we want to know the general solution for this. So if I want to solve this, let me write solution. Okay, first thing you do is you solve for the characteristic equation. The x dt is actually equal to c. Okay, so let's say if there was an a here or something here, then it should have been a over c over a. Let me put it that way. But here we have only c. Okay, so bear in mind that if here was some a, if there was some a here in front of this, then we would have been putting this a here. Okay, this is how it should have been. Okay, but since you don't have any a in front of the t, that is why we have that. Okay, so let's actually solve this characteristic equation. Okay, so if I want to solve this, then this becomes what the x is equal to c dt. Since this is a separable ODE, if I solve this, I will get x equals ct plus some constant s. Okay, so I'll have x minus ct is equal to s, and so I just say that one of the characteristic equation is that s is equal to x minus ct. Okay, so quickly we just take note of this. You can keep this in your mind. Always this will work whenever there's only a c here and there's nothing here. Okay, but if in front of t there was something there, this thing would have changed. Okay, so let's look at the other characteristic equation that will characterize this. That one, you choose tau is equal to t. Okay, so that is also the other characteristic equation that will characterize this PD. So in effect, we'll need these two equations to characterize our PD. Okay, so like what you always do, all you can do is you just go ahead and find your ut and your ux. So let me find my ux first and my ut using this how do you call it, chain rule. Okay, so you use del x times us. We've already done this in our previous video, so I hope you understand this, times u tau, then this should be equal to del s del t times us plus del tau del t times u tau. So you use d is actually, in effect, you are finding your ux and your ut using the tau and s that you have. That is all you are doing. Okay, these are the conditions you use. Then after that, whatever you get for your ux in terms of this, sorry, let me use another color. In terms of this equation, you come and put it back in place of ux. Whatever you get for this one as well. Okay, whatever you get for this one as well, come and put ut, the whole of this ut here. Then you simplify and get answers in terms of us and u tau, and definitely one of them will go away. Okay, alright, so let's go on ahead, and then always remember that these two equations will characterize PD when it is a transport equation. Okay, but in fact I said that the s is being gained from, or is being gotten from, solving the characteristic equation I just wrote. Okay, so put them in mind. Let's go ahead and take examples and know how you go about them. Okay, so example, you have first one is ut plus 3ux equals 0. Okay, so here if you compare this to the previous one, you can see that I have ut in it and I have something ux. So here in effect my c will simply be 3. Okay, so what I can do is I just solve this characteristic equation. Dx dt is equal to 3 over 1, but it's 3. Okay, so I have x, or dx, let me put it that way, is equal to 3 dt. Okay, and I have s equals 3t plus some constant s, and so I'll have x minus 3t equals s. So my first characteristic equation is s is equal to 3 minus 3t, sorry, x minus 3t. Okay, x minus 3t, I have that. Now you see that you choose tau is also equal to t, you choose these two, and that is what you do. Okay, so when you've gotten this, all that we can do here is that, so keep this in mind. If you remember, we just said that s is equal to this, x minus ct, and tau is equal to t. So in effect, this is what you get. But remember that the s is always solvable. You get an equation to get your s. Okay, so with this, let's find our ut and our ux. So ut is simply equal to, we are saying that it is del s del t us plus del tau del t u tau. So this is equal to del s del t is what, minus 3, right? We are differentiating this equation with respect to t, and we have minus 3 us. Then with respect to t, differentiating tau, we get plus just 1. Okay, I have u tau. Now with the other one, ux is also equal to del s del x us plus del tau del x u tau. So in effect, differentiating the first equation, s equals x minus 3t with respect to s, I have 1, so I'll get us. Then tau does not depend on x, so I have 0. Okay, so I have these equations for ut and ux. So simply we come back and put our ut and our ux into the equation. Okay, so let's go ahead and put it there. Ut is this, and our ux is also this. Okay, so let's go ahead. Ut is, if you remember, we said ut is minus 3 us plus u tau. Okay, I have minus 3 us plus u tau, that is ut. You are putting them back in this equation. Okay, so ut is that, then us is this, but there's a 3 multiplied to it, so 3 us become plus 3 us, and this should be equal to 0. Now this can take this off. Okay, so I have u tau should be equal to 0, but this time u is in terms of s and tau. Okay, this u is a function of s and tau, so u of s and tau is now equal to a constant. Okay, but a constant is actually in terms of what, s is an arbitrary function, so it becomes f of s, and u xt should be equal to what, f of the x is what, if you remember, sorry, our x is simply this, x minus 3t. Okay, so x minus 3t, and that will be the solution for this. Now this is a general solution, okay, for our question, but if you remember, we've been given some initial conditions. Okay, so let me write this somewhere. Okay, let me write a general solution somewhere, and then come and find a particular solution, because we're given some of the initial conditions. Okay, I hope you understand this. So this is basically how the transport equation is being solved. Okay, so you don't have to chew any formula. We've gotten our f of st is equal to capital F of x minus 3t. Okay, this is our solution. Now we said that u of s comma 0 is always equal to sine s from the question. This is the initial condition, okay? Then it means that using this equation, u of s comma 0 is equal to putting s in place of here and 0 in place of t. I'll get f of x, okay? And you are saying this is what? Sine x. I hope you understand this. So it means for every f of something, here in the bracket, the answer is sine of the same thing that is in the bracket, okay? So it means that our u of xt or s comma t, which is equal to f of x minus 3t, is actually equal to sine of the particular solution for this. Let me put it that way. It's actually equal to sine of whatever that is in the bracket of f of x, so it becomes x minus 3t. Okay, so this is our solution to the question given. Okay, u of xt is that. So let me just highlight it for you. So this is it. Okay, so let's go ahead and look at a different type of question. This question is very simple indeed to solve. Very, very simple. Let's look at a different question where you have almost all the terms inside. So I have this question to solve. You can see that this is non-homogeneous, and also it has other aspects in it. So quickly, what we do is we said you solve for this particular solution, this characteristic equation, because c here is 1. Okay, so I have 1 over 1, so it means dx is equal to dt. I have x is equal to t plus some s, and we have s equals x minus t. We say tau should also be equal to t. These are the two characteristic equations that will characterize our PD. Okay, now let's look at our ut and our ux. Okay, so what is our ut and our ux? Ut here is equal to the differential of this with respect to t. Okay, so it's del s del t us plus del tau del t u tau, and this should be equal to del s del t is what? -1, then us, so minus us and plus u tau, and ux is also equal to del s del x us plus del tau del x u tau. Now mostly this place is always 0, so we don't actually put it there. Okay, so this should be equal to us. Okay, so you come back and put them back in this equation. So if I put u tau there, ut there, ut is this, so I have to put minus us plus u tau, then plus my ux is also this, us minus u should be equal to, now we are saying that tau is equal to t, so I have to transform the t back, so I get tau. Okay, now this will take this off, I will get u tau minus u is equal to tau. Okay, so you can use the homogeneous and particular aspect to solve this ODE. Okay, or you can choose to use the integrating factor. However way you want to solve it, this will help you, but I will use the particular solution and the homogeneous, because with the integrating factor I'll be doing a lot of integrations. Okay, you just want to avoid doing integrations. Okay, so I have this ODE to solve. U tau, is it minus or plus? So it's minus. Okay, minus u should be equal to tau. Now with the homogeneous aspect, it is u tau minus u should be equal to 0, so the solution to this will give me the homogeneous aspect. Okay, so let me solve this. with this, the integrating factor if is equal to e to the power integral of -1 the tau, okay, whatever that is in front of the u. So I'll get e to the negative tau, okay. So I just have to come and multiply it through, and I'll get something like e to the e to the negative tau, then u tau minus e to the negative tau u should be equal to 0. So I have d of e to the negative tau u tau, e to the negative tau u, okay. When you differentiate this, you get whatever that is up here with this equation. It should be equal to 0 the tau, okay. So it should be with respect to tau. We've actually done this several times in our most of our previous videos, so that is why I didn't go through the process. You can watch the previous videos and you understand this, okay. Now with this, you could see that the solution is simply e to the negative tau u should be equal to some constant, okay, and the constant should be in terms of s, since we have tau here, okay. So with the homogeneous solution, I'm coming to write it here for you, okay. If you remember, I've already done this video or this type of videos in our previous videos, so I hope you understand this. So with the homogeneous parts, u homogeneous, let me put it here, u homogeneous is equal to e to the power tau then f of s, simply making u the subject from this equation, okay. I hope you understand, okay. Now with a particular solution, you say that you look at whatever function that is at the right side of the equation, the main equation, this equation, and you see that it's just tau, so it means it's a polynomial in terms of tau with first degree, okay. So we say that your u particular should be equal to that polynomial, the general function of that polynomial, and every general equation for a polynomial with first degree is written as some a times that variable plus some constant b, okay. So it's a tau plus b. And now when you differentiate this with respect to tau, since we have u tau here in our equation, I have to find u tau. U tau is equal to a, okay. So I'll come back and put them in the equation and solve for my a, that is for a and b. So u tau is a minus u is what? A tau plus b, so it becomes minus a tau minus b, then this is equal to tau. So I have a minus b, or let me write the variable part first. A tau plus a minus b should be equal to tau plus 0. Okay, so now comparing both sides, you can see that minus a here. Okay, let me clean the top for you. I want to do this in this page or on this page. I don't want to go any place, so kindly bear with me. So we see that a here is equal to this minus a is equal to 1, so a is what? Minus 1, okay. Then a plus b is also equal to 0. A minus b is equal to 0, okay. So a minus b is equal to 0, and this means that my a here is equal to b, so simply b is equal to what? -1. I hope you get it. Since they are the same, a is equal to b, so whatever I get for a is the same as b, okay. So let's come back and write a solution for the particular, or our particular solution, okay. So with the particular solution, what you can say is u particular, okay, since we have the a and b, those stuffs here, let me put it, we said it's a tau plus b, so a is what? -1, so minus tau minus b, sorry, b is 1 minus 1, so minus b, like that, okay. Since it's a tau plus b, so when I put it there, it becomes minus tau minus 1. So this is my particular solution. So I simply come back here and write my solution for this whole question that we were solving, and we are saying that the solution is u of st, or let's say s tau, since we are dealing with tau and s, it should be equal to u homogeneous plus u particular, okay. And now my u particular is this, then plus the u homogeneous. So I have e to the tau f of s, then plus, or you can say minus. Let me write it first, and then I'll simplify it for you. So this whole thing should be equal to, writing these ones first. So I have e to the, let me write this one first and factor -1 out, tau plus 1, or 1 plus tau, let me put it that way. Okay, so it's supposed to be 1 plus tau. Okay, so 1 plus tau. Now let's go back and look for our f of s, or our s, and our tau. Okay, so we have s and tau here. If you go back to our previous discussion, you can see that s is actually this. Okay, s is this one, and this is our tau. Okay, s is x minus t, and tau is t. So you come back to our equation, then let me pull it up there and write our answer here. So you could see that our solution to this question is u s comma t, u of x comma t should be equal to e to the power t f of x minus t, okay, minus 1 plus t. So this is the solution to our question. In fact, since we have f of something, this is actually a general solution to it. Okay, so with this, I believe that any first order PDE that is being given to you, either it is a transport equation or any of the forms we've discussed so far with the first order PDE, you can solve it. Thank you, and don't forget to subscribe to my channel for more videos.